Okay, so you are asked to find the indefinite integral. Okay, remember that's just another way of saying find the antiderivative. And I mentioned earlier there's also something referred to as a definite integral, which we're not even going to get into in this section. A definite integral, as you'll see later, will have a little number here at the bottom of this symbol and a little number at the top. But if we don't have numbers there, then it's referred to as an indefinite, meaning we don't know for sure exactly what it is. Okay, so in this case, you're asked to integrate just a number, the number 8. So if you'll look at your list, that would actually be the second one that you have on the list, which the rule was to integrate k. And when you integrate k or any number, any constant, then it's just going to be that number x. So this is just a matter of memorize these rules, okay? Of course, you know to use the variable x here because this right here says that you're doing all of this with respect to x. So if this said dy, then you would just put 8y here. Now, one thing you've got to remember on each one of these indefinite integrals is you have to put plus c. Now, if you want to double check yourself, can I take the derivative of this and get this? So the derivative of 8x is 8. The derivative of a constant is 0. That's why all you have over here is just the 8. Okay? All right, the second one that we have here, this is going to be your power rule. Well, and I actually referred to fourth power a while ago. I didn't realize that was my example. But you're just going to simply increase your power by 1 and then divide by that power. And then again, don't forget your plus c. Okay, the third example is showing you the third integration formula that you have on the list where you have a number times a function. Now you'll get to where you can just do this in your head, but what that means is you can just pull the 7 out front and just do 7 times x dx. Okay, so now following the integration rules, you just bring down your 7 times. This is just going to be your power rule. It's the first power. So you're going to increase your power by 1 and then divide by that power. And of course, there's two different ways you could write this. I mean, if you wanted just to write it all as one big fraction, you could with a 7 on the top, or you can just pull 7 halves out front. Of course, if you're going to pull the fraction out front, just make sure that you keep the x squared beside it. It's not on the bottom, okay? Now, just like with finding a derivative, it's really useful sometimes to think about the fact of rewriting your problem sometimes before you start your integration. And in this case, what you would want to do is bring your y to the fourth to the top, of course, which would make it y to the negative 4, okay? So see, since this involves y, we have dy here. Okay, now you've got the constant multiple here, so remember that's just the same, or you can just write it as pulling it out front and just kind of get that out of your way. So that means you'll just have 2 times, and now you apply your power rule on y to the negative 4, so you increase your power by 1, divide by your power plus c, and then you could simplify this to be 2 divided by 3y cubed. Of course, you would have to bring this to the denominator in order to write it with a positive exponent, okay? All right, same thing rewriting here on number 5. Now, kind of doing 2 things in one step here. You have a constant multiple here of 1/6. So I'm going to pull the 1/6 out front, and then I'm going to take x squared to the top and make it x to the negative 2. So at this point, this is similar to the one I was doing just a minute ago. So we have 1/6 times, and using our power rule, we're going to increase our power by 1 and divide by that power plus c. So simplifying this, I could rewrite this as just negative 1 over 6x. Of course, your 6 stays in your denominator, but you're going to move this to your denominator so that you'll have a positive exponent. Okay, number 6. Now this one's a little bit different. Just kind of compare something here a second. Look at the two problems. This is the one that I just finished working for you. Like in this case, when I rewrote this problem, I pulled the 1/6 out front and took the x squared to the top. But this one's not going to work that way because the 6 is included as being to the second power. Okay, so you have to deal with this one in a different manner. You are going to want to rewrite this. You can't pull out a 5/6 because, like I said, the 6 is tied up here in the parentheses. You do have a constant multiple here of just 5. I'm going to go ahead and pull that out front. But then this being to the second power in parentheses, all of this has to go to the top, of course, which now it's to the -2 power, okay? So 5 times, now you use your power rule on this, okay? So that means you're going to increase your power by 1. And then you're going to divide by your power plus c. Okay, so rewriting this, I can say that I have a -5 divided by 6x. Now you can actually drop the parentheses off from around the 6x because once you move it to the bottom, then all of this is just to the first power. Okay. All right, number 7. Now, this shows that you have a sum, okay? So what we learned how to do a while ago was the fact that we could integrate, or what I showed you a while ago is you can integrate these terms individually. And again, you can get where you can just kind of do this step in your head, but I'm going to go ahead and separate it up so it has the appearance of the two different intervals. Okay. So with the first one, again, the 3 is just a constant multiple, so 3 times. Increase your power by 1, divide by your power. And I'll wait about the plus c on this one since I've got 2 terms, and I'll explain why I'm going to wait on it in just a second. 5 is a constant multiple times, and then this is going to be increase your power by 1, divide by your power. Now, a textbook would show you to put a plus c here and a plus c here, but c just represents a number. So let's just say my number happens to be a 7 here and down here a 6. Well, even if I have a number of 7 and a number of 6, you add those two things together, you still have just a number. You end up with 13, but we don't know for sure what the number is. So it's not that you have to represent it separately. You can just go ahead and integrate the terms and then just put the c last. So just kind of cleaning this up a little bit, you can just rewrite it this way. Okay. All right, I need to backtrack here just a second. And as soon as I got started with number 7, I realized what I did on number 6. So we need to go back to number 6 here just a second. And I kind of got ahead of myself and didn't realize what I was doing until, like I said, I'd finished it up. So go back in your notes and let's rethink this for just a second. Okay. I am going to end up using my power rule, but my power rule that I've been using, it only applies just when I have x to a power. The fact that this also includes a number to a power, I've got to deal with that differently, and I apologize. I don't know what I was thinking at the time. First of all, you're going to want to actually square both pieces here. So you'll have 5 divided by 36x squared dx. There'll be a point a little bit later when you learn more about integration where you actually could just leave this like I had, where the 6x is all to the -2, but there you have to deal with that in a different way. So as far as what you need to know or what you can do right now, this is what I actually should have told you to do. Okay, so now that I have actually squared both of those, I can pull the 5/36 out front and then bring the x to the -2 to the top. So now that means that I'll have increased my power by 1, divide by my power plus c. And again, just kind of making things look a little bit better here. You could say that you have a -5 divided by 36x plus c. So this is what I need you to have down for number 6 instead of what I had done the first time. Because actually doing it the way I had started to do it with number 6, I was thinking ahead of what you'll learn how to do later on. Okay,